Imagine the moment when you find yourself in front of a reflective surface, like metal, expecting to observe your own image, but what appears before you is emptiness, a disturbing absence. This experience defies common sense, as the natural expectation is that the reflex is automatic, something certain. The feeling of strangeness comes as a shock to the mind, which, accustomed to familiar patterns, does not know how to deal with this perceptual failure. Everyday perception is so ingrained in our experiences that we rarely stop to question its veracity. When something doesn't behave as expected, panic arises. This panic does not just originate from not seeing one's own image, but from something deeper. The breaking of a reality that seemed solid and predictable. By not finding their own reflection, the observer was thrown out of their comfort zone, facing the unknown. This also calls into question the trust we place in our senses. Our perception is limited and sometimes fails to give us a complete or accurate view of what is around us. This event creates a fissure in reality as we know it, forcing us to reconsider what we believe to be real. This experience is similar to a breaking of what we call the illusion of control over our perception. When we rely completely on our senses, we are not prepared to deal with their flaws. The absence of the observer's reflection serves as an extreme example of how small deviations in our perception can trigger feelings of restlessness. We feel helpless when our mind cannot process something unexpected. This estrangement is not something purely emotional, but is also cognitive. The human mind constantly seeks patterns and predictability. When these patterns break, the brain enters a state of alert, seeking to restore order. The feeling of panic comes from this momentary inability to align expectations with reality. The observer's despair is both a biological and a psychological reaction. This situation leads us to a profound question. To what extent can we trust what we perceive? What happens when the reality that seems so concrete to us turns out to be inconsistent? Welcome to the Eye of the Soul channel. The idea that reality is a controlled illusion is not something mystical or purely philosophical, but rather a concept widely discussed in modern neuroscience. What we perceive as reality is, in fact, the result of intense and continuous brain processing, which interprets the stimuli received by our senses. Our brain builds an image of the external world based on electrical signals, reorganizing this data to create a functional version of reality. This suggests that the world we perceive is not, in fact, a faithful representation of what exists, but rather a filtered and adjusted version. This concept is based on the premise that the brain seeks efficiency when processing reality. It needs to make quick and accurate decisions about what is important for our survival, and to do so, it creates shortcuts. Instead of analyzing every detail of the environment in real time, the brain uses previously established predictions and patterns to interpret what we are experiencing. This adaptation is what allows us to move efficiently in a dynamic, ever-changing world. When we talk about controlled illusion, we are referring to the fact that this reality created by the brain is adjusted based on what we already know and what the brain expects to find. It controls what we perceive, eliminating details that it does not consider relevant and highlighting what seems important. The process is not conscious, but automatic. By filtering reality in this way, the brain can reduce processing time and save energy, becoming more efficient in carrying out everyday tasks. This does not mean that we live in a completely illusory reality, but rather that it is optimized. What we see, hear, and feel is a simplified version of what is really out there, but for all practical purposes, it works. However, this simplification can also mislead us. In specific situations, when the brain fails to correctly predict what is happening around us, we can experience illusions, distortions, or even hallucinations. Modern neuroscience explores this ability of the brain to create a reality that is useful, but that does not always correspond exactly to the physical world. Experiments with visual and perceptual illusions demonstrate that it is relatively easy to trick the brain into believing that something is real when it is not. This reinforces the idea that our perception is shaped by brain interpretation and not by objective reality. This concept challenges the way we normally understand the world. Instead of seeing reality as something fixed and unchanging, we are forced to reconsider our trust in our senses. The reality we perceive is a construct that serves a specific purpose, but does not necessarily reflect the totality of what is around us. What we call reality is, in fact, a complex interpretation made by the brain. The perception we have of the world around us is not an exact reproduction of what is out there, but a construction based on the electrical signals that reach the brain through our senses. When we see a tree, for example, we are not actually seeing the tree itself, but rather the result of the brain processing the nerve impulses generated by the eyes. This process transforms the light reflected by the tree into an image that makes sense to us. Sight, sound, touch, smell, and taste operate in a similar way. Our senses capture stimuli such as sound waves or scent particles and convert them into electrical signals that the brain can interpret. However, what we perceive is not the raw stimulus, but the brain's interpretation of that data. The result is a perception that makes sense to us, but which may be very different from what objectively exists in the physical world. This reality construction mechanism is what allows us to navigate the world efficiently. The brain uses sensory data to create a map of reality, which we use to interact with the environment. This map, however, is not perfect, is adjusted and simplified to save energy and time. Instead of processing every detail of what's around us, the brain focuses on the most relevant aspects, filling in gaps based on previous experiences and recognized patterns. Modern neuroscience demonstrates that much of what we perceive is actually an internal projection of the brain, rather than a direct representation of external reality. This is evident in experiments with sensory illusions, where the brain is easily fooled into incorrectly interpreting the signals it receives. In many cases, the brain prefers to trust its own expectations rather than sensory data that contradicts those expectations. Hallucinations are also an extreme example of how the brain constructs reality based on electrical signals. During a hallucination, the brain generates perceptions without any external stimulus, showing that it is capable of creating complete and convincing realities from its own internal activity. This reinforces the idea that perceived reality is, to a large extent, a mental construct. Our brain doesn't just receive information passively, it anticipates what we are likely to perceive in each moment. It acts like a prediction machine, always one step ahead, using past experiences to form expectations about what's to come. This is essential for survival, as it speeds up our reactions to the environment, allowing us to make quick and effective decisions. At every moment, the brain formulates hypotheses about what the senses will capture and adjusts its perception accordingly. This predictive process happens automatically and unconsciously. When we enter a room, for example, our brain already expects to see walls, furniture, perhaps a window, based on previous experiences with similar environments. These expectations help speed up the recognition process. If something is out of place or unexpected, like a strange color or an unusual object, the brain will notice the discrepancy and adjust its perception to better understand what is happening. These predictions are based on what the brain has learned over time. From birth, we begin to store sensory memories and experiences that serve as the basis for future interactions with the world. As we grow, the brain becomes more efficient at using this information to accurately predict what is likely to happen in a given situation. This way, the brain does not need to process all the details all the time, which would be energetically costly. Instead, he makes informed guesses about what he will find. When the brain's predictions align with reality, we feel like everything is normal and as it should be. However, if expectation doesn't match reality, for example, if the sound of a car engine we expect to hear sounds like something else entirely, the brain springs into action to adjust its predictions. This may cause a brief feeling of surprise or confusion until the new stimulus is processed and understood. Context plays an important role in this predictive mechanism. In familiar situations, the brain makes predictions based on the current environment without much effort. But in new or unpredictable scenarios, the brain has to work harder to adjust its expectations. If we are in an unfamiliar place or a completely new situation, the brain becomes more alert and attentive to new stimuli because it does not have a history of predictions to rely on. The way the brain deals with perception involves a constant comparison between what it expects to perceive and what the senses actually capture. When the brain's sensory expectations match what is happening in the external environment, the brain validates these perceptions as correct. This means that the world presents itself in a coherent way and within the predictions that it had already established. This alignment between expectation and reality creates a feeling of normality, where everything seems as it should be. This process happens so quickly that, most of the time, we don't even notice it. In common situations, like walking down the street or talking to someone, our perceptions often align with what the brain has predicted, creating a continuous sense of stable reality. The brain saves energy by not having to recalculate or adjust what was already predicted. This allows us to act fluidly and without interruptions, trusting that what we are experiencing corresponds to reality. However, when reality contradicts what the brain expected, a situation of disconnection occurs. Imagine being in a room where you expected to hear silence, but suddenly a loud, unexpected noise happens. This deviation from expectations causes the brain to reevaluate what is happening and adjust its perception to include the new sound. This can generate a brief moment of surprise or even confusion while the brain makes this correction. This adjustment of the internal model of reality is essential for our survival. When something doesn't fit predictions, the brain promptly recalibrates its expectations to better reflect what is occurring. This keeps us connected to our environment and allows us to respond more effectively to new information. It is an adaptive mechanism which ensures that our perception remains flexible and able to deal with unexpected changes. The interesting thing is that even during these corrections, the brain is still seeking efficiency. It does not revise the entire model of reality, but focuses on the elements that do not align with your expectations. For example, if something is visually out of place, like an unexpected shadow in a familiar room, the brain quickly adjusts just that part of the perception without questioning the rest of the environment. This minimizes the cognitive effort involved. This ability to continuously align and correct perceptions is what allows us to interact with a world that is not always predictable. Although most of our experiences follow the expectations that the brain has created, when they do not align, this adjustment function kicks in quickly and automatically. This allows us to function efficiently even in dynamic and uncertain scenarios. Our brain makes predictions all the time, often without us realizing it. A common example of this is recognizing familiar shapes and colors in our environment. When we enter a familiar room, the brain already predicts where the furniture is positioned, the color of the walls, and the lighting in the room. This happens so naturally that we rarely notice how hard our brain works in the background to ensure this feeling of familiarity. When walking down the street, this same process occurs even more dynamically. The brain already expects to see the blue sky, hear the sound of cars, and feel the wind on the face. It automatically recognizes trees, buildings, and other common elements. Instead of analyzing each object in detail, it uses already stored information to process the environment more quickly. This instantaneous recognition of shapes and colors is one of the ways the brain maintains efficiency in processing sensory information. A more specific practical example is the way we identify faces. The brain is wired to recognize faces quickly, which explains why we can easily distinguish acquaintances from strangers, even in crowded environments. This facial recognition is based on predictions that the brain makes about the expected proportions, colors, and characteristics of a face. When we meet a familiar person, the brain aligns these expectations with reality, resulting in immediate recognition. Another practical example involves what we see when we drive a car. The brain constantly predicts the movement of other vehicles, pedestrians, and obstacles, allowing the driver to react quickly to any changes in the environment. These predictions are essential for driving safety and efficiency. When something in the driver's field of vision doesn't behave as expected, like a car stopping suddenly, the brain processes this discrepancy quickly to avoid accidents. These examples show how our sensory expectations directly influence how we perceive the world around us. Moment to moment, the brain uses prior information to simplify sensory experience, allowing us to function quickly and efficiently. However, the brain's flexibility in adjusting these predictions is what keeps us prepared to deal with the unexpected, ensuring that our perceptions remain accurate even in an ever-changing environment. Sensory illusions happen when there is a mismatch between what the brain expects to perceive and what the senses actually capture. Our brain is constantly making predictions about the environment based on past patterns, but sometimes these predictions don't match up with what's actually happening. When this occurs, we have the feeling of an illusion, where our perception does not faithfully reflect reality. These illusions are clear examples of how perception is shaped by the brain's expectations. A classic example of visual illusion is the well-known Miller illusion, where two lines of equal length appear to be different sizes due to the arrangement of the arrows at the ends. The brain, based on its experience with perspective and depth, misinterprets the lines, adjusting perception based on predictions that, in this case, do not correspond to reality. This type of illusion demonstrates how the brain can be deceived when its expectation does not match what is actually present. When the brain realizes that its predictions are wrong, it needs to make adjustments to the perceptual model to align with reality. These adjustments can be immediate, like realizing that an unusual shadow is just a play of light and not something threatening. But in other cases, such as persistent illusions, the brain may take longer to correct its perception, or even fail to adjust it altogether. Illusions show that human perception is highly adaptive, but also susceptible to error. They occur because the brain works to save energy and time by making assumptions about the world around us. When these assumptions fail, we experience a disconnect between what is real and what the brain makes us perceive. Rather than being a complete failure, this process of continuous adjustment is a demonstration of how efficient the brain is at trying to deal with discrepancies and updating its understanding of the environment. These corrections are fundamental to our interaction with the world. Without this ability to adjust our perceptions, we would live in a constant state of confusion, unable to distinguish between what is real and what is the brain's faulty prediction. Thus, illusions reveal both the capacity and limitations of the brain when constructing our experience of reality. The brain is always adjusting its predictions in relation to what the senses actually capture. This process, known as prediction error minimization, is fundamental to cognitive efficiency. At each moment, the brain compares what it expects to perceive with the actual sensory data, and if there is a discrepancy, it corrects its predictions. This continuous adjustment allows the brain to quickly and accurately refine its model of the world, saving resources and keeping our perception of reality aligned with what is actually happening. This correction mechanism is one of the main reasons why the brain can deal with the environment efficiently. Instead of processing everything from scratch every second, the brain relies on previous predictions and only adjusts when necessary. For example, if you are walking down a familiar street, the brain already knows what to expect, adjusting only for small details, such as a passing car or a change in the weather. This saves energy, allowing the brain to focus on situations that require more attention or quick responses. One of the central elements in this process is the constant feedback that the brain receives from the senses. If something doesn't match expectations, such as a different tactile sensation than expected when touching a surface, the brain quickly updates its perception. This continuous cycle of prediction and correction is what keeps our sensory experience accurate and functional, even in a world that is always changing. The error minimization process also applies to more complex interactions, such as communication. When we hear someone speak, the brain anticipates the words to come based on the context of the conversation. If the person says something unexpected, the brain immediately adjusts its interpretation, processing the new data and reformulating its expectations for the rest of the conversation. This quick adjustment is crucial to maintaining fluid communication and avoiding misunderstandings. The rubber hand experience is a striking example of how perception can be deceived. In this experiment, a person places one of their hands out of view while watching a rubber hand in front of them. The real hand is stimulated synchronously with the fake hand, and after some time, the brain begins to associate the rubber hand as part of the real body. The person begins to feel the touch as if the rubber hand were their own, an illusion that reveals the flexibility with which the brain can be manipulated to adopt new bodily perceptions. This experiment demonstrates how the brain can be tricked into accepting a different reality, even if the sensory data does not correspond to physical reality. This happens because the brain is predisposed to integrate visual and tactile information into a single coherent perception of the body. When synchrony between touching and seeing the rubber hand is maintained, the brain begins to prioritize visual information, adjusting perception so that the fake hand appears part of the body. This type of perceptual manipulation shows us that our body perception, which normally seems fixed, can easily be distorted by external stimuli. Another example of sensory manipulation is the experience of Ganzfeld, which explores how sensory isolation can alter perception. In this experiment, participants are exposed to a homogeneous visual and auditory field, such as diffused light and constant white noise, for an extended period. Without sensory variations, the brain begins to fill in the absence of stimuli with its own creations, resulting in visual or auditory hallucinations. This is because, without new sensory data to process, the brain begins to generate its own perceptions in an attempt to make sense of the environment. These hallucinations induced by Ganzfeld demonstrate how the brain needs continuous stimulation to maintain an accurate perception of reality. When deprived of sensory information, he begins to improvise, creating illusions that have no basis in the physical world. This reinforces the idea that our perception of the world is shaped by the way the brain processes incoming signals. And when these signals are limited or manipulated, the perceived reality can change drastically. Both the rubber hand experience and the Ganzfeld show that perception is highly flexible and that the brain can be easily fooled. By modifying sensory stimuli in a specific way, it is possible to manipulate the way the brain constructs reality. These examples are powerful signs that what we perceive as reality is not necessarily a faithful representation of the world, but a construct that can be changed under certain conditions. These experiments raise questions about how much we can trust our everyday perceptions. If the brain can be tricked into accepting a fake hand as part of the body or generating hallucinations in a controlled environment, to what extent is our experience of the world a solid construct? The ease with which perception can be manipulated indicates that the reality we live in can be much more malleable than we imagine, leading to reflections on the very nature of our existence and the role of the senses in the construction of this experience. Psychedelic substances, such as mushrooms containing psilocybin, act directly on the brain's neural networks, destabilizing the prediction process that normally guides our perceptions. They change the way brain regions communicate, mainly affecting the balance between ascending connections, which bring information from the senses, and descending connections, which generate predictions and expectations. Under the influence of these substances, the brain loses part of its ability to impose a rigid predictive model on reality, which allows new sensory interpretations and hallucinations to emerge more easily. During a psychedelic experience, the brain's usual predictions are loosened, allowing unusual or even entirely new insights to emerge. This occurs because ascending sensory signals, which are normally organized rigidly by predictive expectations, begin to flow with less restriction. The result is vivid hallucinations, where colors, shapes, and sounds are perceived very differently than usual, often leading to feelings of interconnectedness and distortions in the perception of time and space. This imbalance between brain connections also allows areas of the brain that normally do not interact as intensely to communicate more freely. Research shows that substances such as psilocybin reduce activity in neural networks responsible for maintaining the normality of perception, such as the default mode network, which is associated with our sense of self and the linear perception of time. With this network weakened, the brain begins to operate in a more chaotic way, allowing perceptual experiences that are very different from those normally accepted as reality. This change in perceptual processing can lead to an expansion of consciousness where the individual feels less trapped in conventional thought patterns. However, it can also result in confusion or disorientation as the brain loses the ability to organize perception in a coherent and predictable way. The absence of firm predictions can cause the brain to construct alternative realities, often seen as visual, auditory, or even tactile hallucinations, which do not correspond to physical reality. The use of psychedelics has been explored in therapeutic contexts precisely because of this ability to break rigid patterns of perception and thought. In therapies with psilocybin, for example, patients often report an ego dissolution, where the separation between the self and the surrounding environment becomes blurred. This is seen as a therapeutic effect for people suffering from disorders such as depression and anxiety, as it allows the brain to temporarily escape rigid and dysfunctional mental patterns. Although psychedelic substances can induce these dramatic changes in perception, it is important to remember that these effects are temporary and depend on the dosage and context in which they are used. The hallucinations and altered sensations resulting from these substances show us that the reality we perceive is a construct of the brain, and that when predictive processes are altered, our experience of the world can be transformed in profound and unexpected ways.